All right, we are in start of chapter 5, section 1, where we're going to use properties of exponents. Some of this may be a review, and some of which is not. So first off, let's start off with the things that are probably similar. We have in the notes some terms that that'll help us um, solve problems through use the property names of the exponents. First of which is product of powers property. What this states is that if we have two bases that are the same and we're multiplying them and they have exponents attached to them, we can add those exponents together to get a solution. So say we had the definition, we had a to the m power times a to the n. This ends up equaling a to the m plus n. So for instance, if we had, say, 4 squared times 4 cubed, we have the same basis of 4. That means that we can add the exponents together, so that's 4 to the 5th, or that also equals 1024 if we take 4 times 4 times 4 times 4 times 4. The power of a power is if we have a value that is to a power, let's say m, and then that is also to a power n. This means that we can multiply those exponents together, so then it's a to the m times n. So if we had something like 3 squared all cubed, we could say that this would be 3 to the 6th power, or 729. The power of a product is, let's say we had two values inside a parentheses. So like say we had a times b, and we had them to the m power. This means that both values inside that parentheses can be an exponent of that power m. So this would end up equaling a to the m times b to the m. So if like I had an example like say 3x squared, this means that we would have 3 squared and then also x squared, which then this equals 9x squared. Negative exponents state that if, say, we had a to the negative n power, that we could write it as a positive exponent if we used the reciprocal of a to the m. So this actually means a to the m power. So a to the negative n ends up equaling 1 over a to the m. So like if I had 7 to the negative 2 power, this ends up equaling 1 over 7 squared, which ends up equaling 1 over 49. Zero exponents states that if you have a value that's not equal to 0, let's say that we have a which is not equal to 0, and we go to the 0 power, this will always equal 1. Saying that, like if we had 510 to the 0 power, this would equal 1. Quotient property is if we had two values of the same base, so we had a divided by a, and we had exponents, say, m and exponent n, what we would do is we could take those exponents and subtract them. So then we'd have a to the m minus n power. So for instance, say we had 5 to the negative 3 divided by 5 to the negative 8. This ends up equaling 5 to the negative 3 minus negative 8 power, which ends up equaling 5 to the 5th, which then this ends up equaling 1300 and, or I'm sorry, that's wrong. Then ends up equaling 3125. Sorry about that. And then the last one we had is the power of a quotient, which states that, say we had a divided by b in parentheses all to the m power. This just means that that exponent m gets attached to both our a and b, so this ends up equaling a to the m divided by b to the m. And if we had numerical values, say we had 4 divided by 7, and then we squared it, this would end up equaling 4 squared divided by 7 squared, so this ends up equaling 16 over 49. Okay? So since we have those terms and we have an idea of what their definitions are, let's evaluate some of these expressions. So I have negative 3 times 4 to the negative 2 power, all to the negative 2. So first off, what I'm going to do is I'm going to use the power of product and take this negative 2 and attach it to both of our values. So I'm going to do negative 3 to the negative 2 power times by 4. And since that's got a negative 2, I can use the power of a power and say that is 4, is it negative 2 times 2? That's just 4. Then I see that I have a negative exponent with negative 2, so I'm going to use my negative exponent property and say that this is just like writing 1 over negative 3 to the squared times by 4 to the fourth. And then I'm just going to multiply through and then use my exponent, so then this ends up being 256 over 9. Okay? For b, I have 5 to the 7th power divided by 5 to the 8th power, all of which is to the negative 1 power. So first off, I'm going to use the power of quotients, and I'm going to attach that negative 1 to both of my values. So then this ends up being 5 to the negative 7th power divided by 5 to the negative 8th power. Now I can use my quotient property and say that I have the same basis of 5, and I can subtract my exponent. So I have negative 7 minus a negative 8, which ends up giving me 5 to the first power, so then that equals 5. And for c, I have 2 to the 4th times 2 to the 0 power times 2 to the negative 3rd. So what I'm going to do is I'm going to use the property of the product of powers property, and I have the same basis of 2, and so I'm just going to add my exponent. So I got 4 plus 0 plus negative 3. So that ends up being 1, and so that ends up equaling 2. Okay? Here's a quick review on scientific notation. Scientific notation is represented generally by what I'm calling a times 10 to the nth power. A must be either greater than or equal to 1, but it must be less than 10. And if m is a positive number, then I know that it is a large number, and I know that it is greater than 1. If m is negative, I know that it is a small number, and I realize that that value is less than 1. So when dealing with multiplication, say I have an example of a times 10 to the m times quantity b times 10 to the n, I write it as, what I'm going to do is I'm going to multiply a and b together to get a times b. Then what I'm going to use is my power of products property for the tens unit and add those exponents together. Similar in what we're going to do with the division, I'm going to divide a and b together. Then I'm going to multiply it by 10, and then I'm going to use the quotient property and subtract my exponents of 10 together. And then my powers property, say I have a times 10 to the nth power all to the n. means that I'm going to attach my n power to both these values. I'm going to take a to the n, then I'm going to multiply times 10 to the m times n power. I'm going to multiply those exponents. So let's take a look at examples. So I got I got 3.1 times 10 to the fourth times quantity 3 times 10 to the negative 6. So first off, what I'm going to do is I'm going to multiply these two together. And what I get is 9.3. Then I'm going to go times 10, and I realize I'm going to multiplication, so I'm going to add these exponents together. So 4 plus a negative 6 gives me a negative 2. For B, I have 5.6 times 10 to the 10th power divided by 1.4 times 10 to the negative second. So first off, I'm going to take 5.6 and divide it by 1.4. That gives me 4. Now I'm going to multiply by 10. And so now I'm going to subtract my exponents because I'm using division. So 10 minus negative 2 gives me to the 12th power. Okay. I got C, and C here is 1.5 times 10 to the negative third, all of which is squared. So going back to our powers example, I'm going to square 1.5, and the 1.5 squared is 2.25. Now I'm going to go times 10, and now I'm going to multiply my exponents, which gives me 10 to the negative 6. All right. Now I have 3.3 times 10 to the 6 multiplied by the quantity 5.1 times 10 to the third. So I'm going to go 3.3 multiplied by 5.1. This gives me 16.83. And it's times 10, and I'm going to add these exponents together, which gives me to the ninth. The problem we have is that 16.83 is not, it ends up being greater than 10, so what I need to do is I need to get it to be a value that is greater than or equal to 1 but less than 10. So what I'm going to do is I'm going to move this decimal point over here so it's 1.683. So I got 1.683 times 10, and since I moved the decimal place 1 over, I'm going to add an exponent to my powers of 10. So if you didn't see that right away, you can rewrite it back in standard form if you wish, and then make sure that the decimal point is in between the 1 and the 6. This is similar to what we were working with when we were simplifying expressions, but now we have variables attached to them. So for A, I have 4 times b squared times c to the negative third, all to the third power. So first off, I'm going to use the power of product and the power of power rule to take this third power and attach it to each of my numerical values and variables. So this brings me to 4 to the third times b, since it's squared, so I got squared times the third, so that gives me to the 6th power. Then I got c to the negative third times 3, so that gives me negative 9. Now, it doesn't say to make your exponents positive, but if it did, I know that making this c to the negative 9 positive is just to make that into the denominator. So I got 4 to the third power, b to the 6th, divided by c to the 9th. And if I were to simplify 4 to the third power, that would be 64 b to the 6th divided by c to the 9th. Okay, and that's your answer. If we look at example B, I have 42 x to the 4th, y to the negative 5th, and z to the 5th. And I have 28 y to the negative 4 and z squared. So first thing I'm going to do is I'm going to simplify my 42 divided by 28. And that ends up simplifying to 3 over 2. Next, I want to get all of my exponents positive. So I see that I have x to the fourth, that's positive. That works. But I have y to the negative fifth and then z to the fifth, so that works too. So z to the fifth is fine. And I got z squared on the bottom. But I have y to the negative fifth here. So what I'm going to do is I'm going to move that to the denominator, so it's y to the fifth. Now I see I have y to the negative fourth, so I'm going to move that to the numerator, so that gives me y to the fourth. Okay. Now I can look at the similar exponents that I have, and so I'm going to still write it as 3 over 2, and x to the fourth stays the same because I have no other variables in common, no base in common, but I got z to the fifth and z squared, so that means that I can subtract those exponents, make it z to the third, and I have y to the fourth divided by y to the fifth. So if I subtract those, I get y to the negative 1 power, and I can bring that as a positive by leaving it in the denominator. So that is my final answer. For this one, first off, I have 40 x to the 13th divided by y to the 8th, multiplied by the quantity 4y to the fourth divided by 5x to the negative 2, all of which is to the negative 2. So what I'm going to do first is I'm just going to write that first value, 4x to the 13th divided by y to the 8th, multiplied. And what I'm going to do is take this negative 2 and place it to each of my values in the parentheses. So I got 4 to the negative 2. I got y, and since that's to the fourth, I get to multiply my exponents. That gives me negative 8 divided by 5 to the negative half, and I got x to the fourth. Okay, so now what I'm going to do is I'm going to get all of my exponents positive. So I'm still got 40 x to the 13th divided by y to the 8th multiplied, and what it looks like is I'm going to have 5 squared divided by 4 squared x to the fourth y to the 8th. Okay, so now that I look at it, I know that 5 squared is 25. Times that by 4, that gives me 1,000 x to the 13th over, and if I multiply it across, so now I have 16, that's what 4 squared is, x to the 8th, and I got y to the 16th. Oh, I'm sorry, why do I have x to the 8th over here? I'm sorry about that. It's x to the 4th. My apologies. And what I can do is simplify this. 1,000 divided by 16 can be 125 over 2. I can use the quotient property by taking x to the 13th and x to the 4th by subtracting the exponents, which gives me x to the 9th, and I'm left with y to the 16th. Okay. Last examples deal with writing expressions for volume or area in terms of x. And so basically what they're going to do is we realize that the area of a triangle equals 1/2 base times its height. So what we're going to do is this is going to be represented as its base. This is going to be represented as its height. And so we are going to substitute in those values into the area equation. So then I'm left with area equals 1/2 times x squared divided by 3, because that's b, times by h, which then gives me 2x. Well, I'm going to do 2x over 1 because everything else is fractions. So if I were to multiply this across, I would be left with 2x to the third divided by 6. And if I were to bring this in lowest terms, I'd get x cubed over 3. All right. Last example, I have v, which is volume, equals pi r squared times h. So my x here equals r, and this equals h. So if I go v equals pi times, which is r squared, that ends up being x squared, times it by h, which is 4x squared. So I have my v equals pi times 4 times x to the 4th. And that is how we rewrite that expression. And that is being able to use properties of exponents. Hope this helps. Till next time.